Good afternoon. I'm Xin Yin from Zhejiang University. Today, I will present our research on unit test generation. The title is Enhancing LLM's Ability to Generate More Repository-Aware Unit Tests Through Precise Context Injection. Next, I will report from 4 parts, including introduction, approach, experimental results, and conclusion. Recently, LLM-based unit test generation methods have attracted significant attention and shown promising results. However, these approaches still face several limitations because large language models may exhibit hallucination phenomena when generating unit tests for the focal method. These hallucinations can include invoking non-existent methods, configuring incorrect parameters, and specifying wrong return values, among other issues. But in real-world development scenarios, testers are typically well-versed in project specifics. Furthermore, IDEs and language servers can provide information about function calls and identifier definitions, enabling developers to write more accurate code. Therefore, we proposed RATester. It simulates developers' workflow by enabling LLMs to dynamically fetch precise, repository-aware context via hovering over identifiers during unit test generation, addressing imprecise context issues in previous works. RATester has 3 main components. Fetcher fetches the definition and documentation comment of unfamiliar identifiers using the language server. Formulator fills the fetched precise context and the test snippet with newly generated identifiers into the prompt template, and then formulates them as input for the generator. Generator leverages the formulated input to perform the unit test generation task. To equip LLMs with comprehensive knowledge comparable to that of experienced testers, we incorporate the language server tool. When encountering unfamiliar identifiers, RATester utilizes language server to retrieve relevant definitions and documentation comments, subsequently using this global context to guide the LLM in generating accurate tests. Fetcher operates in 2 stages, initially querying LS for the focal method's type information and dynamically fetching definitions for unfamiliar identifiers during generation. The formulator fills the fetched precise context and the test snippet with newly generated identifiers into the prompt template. The template has 4 parts. Task description aids the LLM in understanding the task description, simulating the process by which a human tester comprehends the objectives of the task. The precise context continuously expands as the generation process progresses, simulating the global project knowledge that human testers possess with the assistance of IDE tools. Method under test simulates the scenario in which human testers review the method or function being tested. As for generated test snippet, RATester provides the LLM with a unit test generated in the previous round, along with a new identifier. As this part continues to expand, it simulates the iterative process of human testers writing unit tests. The generator generates new identifiers using the formulated prompt. During the experiments, we evaluated our approach on 3 languages: Go, built on 8 diverse projects across multiple domains; Java, from 4 projects; and Python, from the bus-INPy dataset. We compared against 5 baselines across 3 categories: traditional, learning-based, and LLM-based approaches. As for data leakage, we use the ADK project, a Google-designed project created after January 1, 2024, and we also randomly selected 500 focal methods from Golang projects with commits containing updates, modifications, or creation dates after the model's training cutoff. To investigate the effectiveness and efficiency of RATester, we focus on 4 research questions and 1 discussion. The first one is effectiveness of RATester. Our method achieves the highest compile rate and line coverage, and also detects the most bugs in mutation testing. RQ2 demonstrates the model-agnostic capabilities of RATester, showing that our method consistently delivers strong performance across a diverse range of large language models. RQ3 and RQ4 evaluate the efficiency and generalizability of RATester, respectively. The results show that our method not only generates tests efficiently in terms of time and resource usage, but also scales well across different model sizes, from smaller, lightweight models to large, state-of-the-art LLMs. Furthermore, RATester demonstrates strong cross-language adaptability, achieving consistent performance improvements in unit test generation for Go, Java, and Python. So, this paper addresses the challenge of LLM hallucinations in unit test generation by proposing RATester, which enhances LLM's ability to generate repository-aware unit tests through precise context injection. To provide LLMs with global knowledge comparable to that of human developers, RATester integrates language servers to enable dynamic definition lookup capabilities. That's all for my talk. Thank you.